this. So let's rock this. First of all, we all know we're working with quadratics, okay? Here it says use what, kids? To find the what? To find the vertex of the parabola and the center and radius of the circle, okay? And then graph the equation. Well, again, the graphing part, I'm not too worried about this, okay? Guys, I look at this one right here, and here's what I see. All right. First of all, let me just do a completing the square example with you. What is completing a square? If I had something like this, kids, x squared plus 4x equaled, let me think. Well, we're going to add 4 to both. So how about 12 right here? Okay. Here's how completing the square works. You always set this up. You've got to have an x squared like this here, right? So you set this up as x plus half of your linear term. What's half of the 4? Half of 4 would be 2. You write this as x plus 2 squared. But here's the situation, kids. When I FOIL x plus 2 times x plus 2, if I would FOIL this out, this gives me x squared plus 4x plus 4. Now is the x squared showing up here? Does the x squared show up here? Does the 4x show up here? But is this plus 4 already up here? It is not. Okay, so this is what it really becomes equal to. Guys, the thing that's new over here when I write it as x plus 2 squared is the plus 4. So if I'm adding 4 to the left, to keep this balanced, you would have to add what to the right? Plus 4 to the right. So you would have 12 plus 4. This would have to equal now, we've got 4 extra over here. We just have to equal 16 right here. Okay? And so what ends up happening, kids, is we're going to write this completing the square by writing it as x plus 2 squared. We want this to be a perfect square. But when I FOIL this out, we get an extra plus 4 in here that wasn't up here on the left side already. So we'll keep that plus 4 in there as long as I do what to this side? Add that extra 4 in there. Now, it's a tough concept. You guys just haven't practiced it a lot or enough, I don't believe. Okay? So here's how it would work in our example. First things first. I have graphed the function up here. What does it look like the vertex is going to be for us in this problem? -1, -3. And I'm going to tell you right now, this completing the square thing is not your cup of tea. Where can we still go? In fact, it turns out we can still use our standard form rules to do this. We can do the opposite of b over 2a, plug that value in for a line of symmetry, and be on our way. But I'm just going to show this to you real quickly. Here's how this works. So we want to be able to complete the square on this thing. So guys, what I'm going to do is I'm going to get y alone in this one right here. I know that this first one's going to be a parabola, because x is to what power here, or what degree I should say. Okay, I'm going to get y alone in this, and I'm going to move y over here. So I'm going to say, if I add y to both sides, do you guys agree that this is y equals 2x squared plus 4x minus 1?
Yep.
Agree with that?
Yep.
All right, this is where things just get crazy, right? You can't complete the square unless I have just x squared up front. So what am I going to have to factor out of the x squared part? So this is going to become 2 times x squared plus 4x I'm sorry, I've got that wrong. Should be x squared minus what? Or plus what? Okay. Now, right here, kids, the part in parentheses is the part we need to complete the square with. And again, I'm not a fan of this, so don't panic too much. Just get this down. But guys, what would half of this middle term be right here? What would half of the linear term 2x be? 1. So we're going to write this as 2 times x plus 1 all to what power? Okay, and then there's still what hanging out back here. All right, let me show you this here, kids. This is where things get really goofy. Okay. The thing that we run into again is this. I'm going to FOIL out the x plus 1 over here on this side. Okay, you guys agree this would be x squared plus 2x plus 1 right here. Okay, but I see the x squared plus the 2x in the original problem. What got added in here? So this is like a plus 1 in here. So there's really going to be a plus 1 in here. So this is like equal to 2 times x squared plus 2x plus 1 minus that 1 out here. But here's the deal, kids. We added this 1, but this 1's really getting multiplied by what out here? A 2, isn't it? Okay, so it's really like we added 2. So to make up for the balance of adding 2 on that side, what are we going to have to do? Subtract the 2, right? Okay. So for making up for this 2 times 1 right here of adding 2, we got to make up for the adding of 2 by subtracting 2. So what this ends up, kids, is as 2 times, okay, this could go back into x plus 1 squared. And this here was this. Minus 1 minus 2 keeps it balanced. So really minus how much? Well, 3 in the end. Now guys, isn't that vertex form when I get done right here?
Yeah.
What would go in here to make that 0? Negative what? 1. That's like my h value. H is negative 1. What's your k value? Negative 3. Gosh, what did we say the vertex was going to be? Negative 1, negative 3. I'm just going to go back and look at this. Now again, guys, have it down, but I'm probably going to tell you to do what? I'm probably going to say, you know what? I like this a lot better. Another way we could have done this was this, kids. And I'm going to write this down over on the board here. When we got y alone, I would say go back to your standard form and revert to that. When we got y alone, what do we have? Y was equal to, was it 2x squared plus 4x minus 1? Was that right, guys? Okay, help me out, kids. What's the a, b, and c value on this? A would be 2. What's your b value? And c is? All right, so we said yesterday line of symmetry happened when x was equal to the opposite of b over what? You remember? Okay, what is the opposite of b? And then over 2 times 2, that'll equal what value? Negative 1. So the x value is going to be negative 1. We're going to plug that in up here. So the y value now would equal 2 times, I forgot to square it up there, didn't I? 2 times negative 1 squared plus 4 times negative 1 minus the 1. Okay, help me with some math. Negative 1 squared. 1 times a 2. This is really 2. 4 and negative 1 would be a minus 4, wouldn't it?
Yeah.
Minus 1 more.
Yeah.
So when x was negative 1, y was what value? When x was negative 1, plugged it in, y turned out to be what? Negative 3. So the vertex here would land at. Okay, so I'd much rather have you go that route, I think. Okay? Unless you're a fan of completing the square, but I think if I asked how many people are fans of completing the square to solve that, I bet I would see zero hands in here. Let me ask the question, how many people like the completing the square idea? Gus, I thought you might raise your hand. Just joker. No? Thought about it. Okay, yeah, I don't like it either. All right. Guys, the last one I'm going to tell you, I'm not even going to worry about completing a square for circles, okay? I just want you to understand why the next one is the graph of a circle. Is that okay? So if you take a look at the second one, and I don't even know, we've been talking about parabolas the whole time, and now they want to talk about circles. It doesn't make any sense to me. But the reason this becomes a circle, do I have a quadratic x in here? In other words, x to the second. This starts to become a circle when you don't just have y to the first degree, you actually have a y to what power? Second power. All right. So here's the graph of this one, kids. I would just encourage you to graph that right there. Where does it appear the center is going to be at for that? What coordinate looks like the center? Negative 2, 0. Would you guys agree with that? Okay, so the center would be at negative 2, 0. How about the radius then? How far is the radius? Radius is 2 units, okay? So my suggestion on this right here, kids, just graph. Anything that's a circle, graph it. Okay, we can see the center was where again, kids? What was that coordinate for the center right here? Negative 2, comma 0, right? Okay, so if negative 2, comma 0 here is my center, then the question becomes, what's the radius? Well, the radius would be how long then? 2 units, right? All the way around there? Good. So, if you see anything that says completing a square, probably what do I want you to do? Graph in decimals. We know that in this one here, the center turned out to be negative 2, comma 0. And after that circle, what was the radius again there? Okay, this is a whole other lesson for a whole other day, so I'm not really too worried about this. Okay. So I just wanted to touch on those real quickly here before we move on. My question to you is, I sent out big ideas yesterday. Is there anything you wanted to question on any of those problems at all? I may have at least started that. I haven't started that. Okay, so we'll get some time today to look at that. I'd strongly encourage you in this section to look at some notes right here. Okay. You're going to get a practice today. On this one right here, just the odds first. Okay, just the odds on this one. So here's what I want for you. What's that? Not today, no. These get kind of lengthy here, so I thought I'd shorten it. You guys like those, huh? Give us a puzzle? Maybe I will next session. How's that sound? All right, kids, I'm going to change some directions up on this a little bit, so pay attention to this.
You said only odds?
Yeah, we're only doing the odds, kids, just the odd problems, all right? So, lots of different ways you can choose to do this.